In our simplifying unit, we're going to start off with a refresher of order of operations. Before we look at that, we're going to define what an absolute value is. Absolute value is distance from 0 on a number line. Thinking about the number 5, which is 5 units away from 0 on a number line, and the number -5, which is also 5 units away from 0 on a number line. Distance is not negative. Think about if you live 5 miles from school, you don't say that you drive 5 miles to school and then you drive -5 miles back home at the end of the day. You drive 5 miles. It might be a different direction, but the distance is still positive. That's what's essential to understand about absolute value. Notice there are only 4 steps in order of operations. I understand that a lot of you probably learned PEMDAS for order of operations. I do not like PEMDAS because it has 6 letters, but order of operations only has 4 steps. I get a lot of students who struggle with order of operations, and I think in part it's because of PEMDAS. The first step in order of operations is not parentheses, it is grouping symbols. Parentheses are one type of grouping symbol, but they are not the only grouping symbol you might see. We have some fancy parentheses, and then we have absolute value that acts as a grouping symbol. Radicals also act as a grouping symbol. Anything that is under the radical needs to be simplified before you take the square root, and fraction bars act as a grouping symbol. They group the numerator and the denominator, which need to be simplified separately before you divide. Second step in order of operations is exponents and radicals. The third step is division and multiplication in order from left to right, the same way that we read a book, we read a math equation. And finally, subtraction and addition in order from left to right. Learning target 14 is order of operations, and our essential question is, why do we need an order of operations for mathematical expressions? Before we look at evaluating order of operations, let's start by evaluating absolute value expressions. Our first one, we have the absolute value of 5. How far from 0 is 5 on a number line? We just ran through that one with the vocab. 5 is 5 units away from 0. Example B, the 12 minus 21 is inside the absolute values, which are grouping symbols, so we need to subtract before we take the absolute value. 12 minus 21 is -9, and how far away from 0 is -9 on a number line, and that would be 9 units. Practicing evaluating some order of operations. We have a lot of grouping symbols on part A. Inside the second set of parentheses, we have another grouping symbol, the absolute value. So we'll take care of that first. Adding the opposite, which is the way we subtract integers. 8 plus 4 gives us 12. Adding the opposite again, we have plus 4 minus division comes before subtraction in order of operations. So I can go ahead and divide this. If you look off to the right, one of the key things to remember about an order of operation problem is to chunk them into smaller segments. This way you can perform more than one operation at a time, and it won't take you 16 steps to get through an example. -8 divided by -1 is +8. We're still working inside that second set of parentheses. I'm going to drop the parenthesis around the -6. There are no operations inside that parenthesis. It was just used to separate that as a -6. Inside the parentheses, we have the grouping symbol of absolute values still that we need to take care of. The absolute value of 12 is 12. Finally, inside the grouping symbol, we will need to add all 3 of our numbers together. 12 plus 4 is 16, plus 8 is 24. And finally, -6 times 24 is -144. Example B, we've got a lot of grouping symbols on this one as well. inside this first set of grouping symbols, the negative 16 doesn't necessarily need parentheses, it's just separating that negative sign. We have another set of grouping symbols here that we'll take care of. So I'm going to drop the parentheses around my negative 16. Inside this second set, I need to add and subtract in order from left to right. So I have 10 plus negative 4 is 6, plus 11 is 17, minus 9 is 8. Since I evaluated everything inside that parenthesis, I can drop that grouping symbol as well. Next, I have another set of grouping symbols. 1 minus negative 2 is really 1 plus 2 or 3. I still have one more set of grouping symbols. Negative 16 minus 8 is negative 24. I'm going to drop the parentheses around the 3 and turn it to a multiplication so that we can see we no longer have any grouping symbols. Now we will multiply and divide in order from left to right. So I will do negative 24 divided by 6 first before I multiply by the 3 to get negative 12. My final order of operations question has quite a bit going on. We've got an exponent this time. The exponent is also acting like a grouping symbol. That negative 6 plus 2 times 4 needs to be simplified before I raise the negative 1 to that power. I also have a grouping symbol as my division bar. I need to simplify the numerator and simplify the denominator before I divide. The division bar separates this into two different problems for me, the numerator and the denominator, which I will simplify at the same time. In the numerator, I have that exponent that I need to simplify. Negative 6 plus 2 times 4. We need to multiply before we add. In the denominator, I have the absolute values as grouping symbols. I can also chunk this as a smaller problem as well. Negative 9 plus 8 is negative 1 minus, inside my absolute value, negative 6 minus 2 is negative 8. In the numerator, I'm still working on that exponent. Negative 6 plus 8 is 2 minus 8. In the denominator, I need to take the absolute value of negative 8, which is positive 8. The subtraction sign in between the negative 1 and 8 stays a subtraction sign. It's just that the negative 8 became positive. In the numerator, I have an exponent. Negative 1 squared means negative 1 times negative 1, which becomes a positive 1 minus 8. In the denominator, negative 1 minus 8 is negative 9. Subtracting in my numerator, I get negative 7 over negative 9. 7/9 can't be simplified, but a negative divided by a negative would become positive. So my final answer is 7/9. Now I have an error analysis question. I'm going to run through this problem and I will make a mistake, and I would like you to find and fix the mistake that I make. Starting off, we have powers, so I will do 2 squared, which is 4. Next, I need to multiply. 4 times 2 is 8. After multiplication comes division. 32 divided by 8 is 4. And finally, I will add my 4 plus 5. Again, I made a mistake on this problem somewhere. Make sure you look carefully through the problem. Think about the 4 steps of order of operations and which one was violated. This will be our U-Try question to start our time together.